Alright, in this video we are going to be going over how to convert coordinates and equations from rectangular form to polar form and vice versa. So in order to understand how to do that, first we have to understand that rectangular form is written with x and y coordinates, and polar form is written with coordinates of r and theta. So to picture that, we have r and theta up here and x and y. Now to be able to convert between those two, we can understand the relationship of cosine theta equals adjacent over hypotenuse, or x over r, and therefore cosine theta, we can multiply both sides by r and get r cosine theta equals x. And then we can do a similar thing for sine, with opposite over hypotenuse of theta, and get r sine theta equals y. And that'll help us be able to convert from rectangular coordinates to polar coordinates and such. And then also we can see that the Pythagorean theorem, x squared plus y squared equals r squared. So we have that here, and then tangent of theta is going to be y over x, and we can use that to be able to find theta if we have a y coordinate and an x coordinate. So in order to show how that works, we're going to work through these examples. So this equation, we have the rectangular coordinates of 12 and 30. So we will say r squared equals 12 squared, or 144, plus 30 squared, which is 900. Okay, and then we can take the square root of both sides to get r equals the square root of 1044, or we could put that into a calculator and get r equals 32.31. Then in order to get polar coordinates, we need theta here, so we'll use the relationship of tangent theta equals y over x, or 30 over 12, and we can put that into a calculator and take the inverse tangent of this fraction here and see that theta equals 68.2 degrees. Alright, so converting from rectangular to polar, we'll use these two identities. It's fairly simple. Alright, and now we're going to convert from polar to rectangular. So, since we have, we know what r and theta both equal, because they're given us here, we can set x equal to that and a y equal to the sine of the theta, or r sine theta. So we'll do 6 cosine theta equals pi over 3. Pi over 3 equals x. And if we put that Actually, we don't need to put that into a calculator because pi over 3 is a unit circle angle. So x equals 6 times 1/2, which equals 3. Now we can do the same for y, but we just have to switch cosine over to sine theta. So pi over 3 equals y. So then y equals 6 times square root of 3 over 2, okay, or y equals 3 times the square root of 3. And now that we have converting from rectangular to polar and polar to rectangular under our belt, we can use those same identities to be able to convert equations from rectangular to polar or vice versa. So we'll just hop right in here. We can see that this equation is in polar form, so we want to get it over to rectangular form. And to do that, we know that cosine theta, well, that equals x over r. So we're gonna say r equals 5 times x over r, and then we will multiply both sides by r and get r squared on this side equals 5x. Now we have this side in rectangular form, but we do not have this side in rectangular form, so we can look back at our identities up here and we see that r squared equals x squared plus y squared. So we can just put x squared plus y squared in here. And there's your equation in polar, or in rectangular form from polar form. Moving along, we can move down to this next equation. We see that it is in polar form as well, so we'll be converting over to rectangular form. We see we have cosecant here, so let's go ahead and write that in terms of sine. So 1 over sine theta Alright, and then we can multiply both sides of the equation by sine theta, so we'll get r sine theta equals 15. And now let's take a peek back up here at our relationships, and r sine theta equals y. So it's just as simple as substituting y in here. Y equals 15, and there you have it in rectangular form.